Welcome to SAP. SAP is a spectral audio playground in Unity developed by PeerPlay for real-time signal analysis, visualization and resynthesis. It gives developers and artists direct access to the spectrum of sound and tools to connect audio to visuals, interaction and procedural design. I aspire to release this toolkit on 12/21 of this year on Patron. Let me show you around in the editor of SAP. SAP exists out of 4 main modules that are responsible for the entire flow of data. The first module is that of source, or in other words, the origin of sound. All modules have an input and an output. Source is responsible for converting a signal into a spectrum, which are the measured amplitudes of signals at different frequencies. You can select the audio listener to get all the audio from Unity, an audio source or a specific audio clip. Or you can select PCM to stream Windows Audio or a microphone device. Let's set this to AudioSource, which is linked to an audio source in the scene that has my playlist of sound files. All music has been made by Joey Vermeulen, so thank you for letting me use them. Let's go into play mode to see the source in action. We can now use the volume slider to set the audio louder, or we can mute it altogether, but still get the data. You'll notice a lot of noise on these bins, and to filter out this noise you can select an FFT window in the spectrum output. So instead of rectangular we can go to Hamming or Hanning, and this will make the output more stable. Let's select the line visualizer. You can use the SAP connector component to easily connect all outputs from SAP to specific methods on your scripts that have a float array parameter. In this example I use only the negative values, so my line scales inwards. We can also make the line scale outwards or use the full range. We can also adjust the smoothing to get smoother results. This way you can already get some nice variation in results. Outside of play mode, the editor shows visual feedback when changing the sample size. Let's set it to 16K and have a look at the second module. Spectrum, the module of transformation. It transforms linear spectrum from source into a more useful spectrum. It lets you scale the amplitudes by using a strategy such as power and remap frequencies into bins that reflect how we hear sound. With Hertz you can choose the exact frequency ranges, and with MIDI the bins align with musical notes. Now we have a more meaningful result, but it's still missing some character, and that brings us to the third module, gate. Gate is the module of interpretation. Here the bin values are always normalized between 0 and 1 and safely available for visualization. You can see the difference with the red spectrum bins that go to unexpected heights. With gate you can apply filters to design expression. Right before the normalization we can apply contrast that works similar to, for example, Photoshop. If I set the contrast very low, you can see a wider range of results that were otherwise too low to get picked up. We can mix and match multiple gates for different behavior. Currently the connector of the visualizer uses the same gate for the base color, emission color and scale. Let me set the emission to use gate 1 and the scale to use gate 2. Now we have a richer result with more variation and expression. The fourth module is signal, the module of manifestation. Signal takes in the spectrum of gate and outputs a new signal, a new sound. Signal is what makes SAP not just an analyzer, but an instrument for creative input. Now let's use, instead of music, my voice of the SAP sequence. To get better results for dialogue or spoken word, I'm switching the amplitude scaling to decibel. With this option you can better detect the silence between words. 24, 12, 4, 2, 1. We can now adjust the wave type, pass filter cutoff and any setting in the chain to create a different sound and visual. 21, 42, 24. Depending on how wide or narrow you set the spectrum, we can emphasize different frequencies. To improve the sound, you can also add a post-process filter from Unity on a signal, like reverb, or echo. Now that I've covered the basics of what Spectral Audio Playground can do, remember, this is just the beginning. I'm planning to add live BPM and pitch detection, sequencers and wave shaping tools. Most of these features will come after the first release. Speaking of release, once SAP is out, you'll be able to log in to SAP with your Patreon account. Your tier will unlock higher sample rates and spectrum sizes. There will be a 12 Hz version for hobbyists, 21 Hz for creators who want more precision, and 42 Hz for commercial use. I'm building this tool without a budget, and your support makes a huge difference. If you'd like to help me develop SAP, you can become an early adopter by joining my Patreon. Right now I've set up 2 tiers, 12 and 21 Hz. And as a thank you, early adopters will automatically get upgraded benefits when SAP releases. To stay updated with the development, subscribe to the PeerPlay YouTube channel or join as a free member on Patreon. Thanks for watching and have an awesome day.